Good afternoon, guys. This recording is for Algebra 1, Chapter 5, Lesson 5. We're talking about parallel and perpendicular lines. No quote, because I want this video to stay as short as possible. Alright, parallel lines are lines in the same plane that never intersect. They go on forever in both directions and will never hit each other. Parallel lines are parallel because they have the same slope. But they do have different y-intercepts. Now, if they had the same y-intercept and the same slope, they would be the exact same line. But since they have the same slope but different y-intercept, that means that they are actually not the same line, but they do go on forever in the same direction and are the same distance from each other the whole way along forever, but end up not being the same line because they start at different points. All right, so here's two examples. We have y equals 2/3 x plus 1 and y equals 2/3 x minus 3. So as you notice, the slope, which is there, 2/3 is the same for both equations, but the y-intercepts are different. So if I went ahead and graphed them, there's the green circled equation, the intercept of 1, and then going up 2 and to the right 3. And then I graph the next one, which is purple. It's starting at -3 and going up 2 and to the right 3. So they are parallel. They look very parallel. Now, of course, I'm not perfect. I'm not a machine. My graph could probably be done a little cleaner, but, you know, it's a good representation of a pair of parallel lines. Okay, moving on. So, are the graphs -6x plus 8y equals -24 and the graph of y equals 3/4 x minus 7 parallel? So the thing is that the first graph is in standard form. So that one's in standard form. It's in ax plus by equals c. And this graph is in slope-intercept form, which is y equals mx plus b. So they're not in the same form, which means it's going to be very difficult to compare them. The other thing is that the second one, the one in slope-intercept form, it has the actual slope in it. So what we need to do is actually convert the first equation that's in standard form to y equals mx plus b format to slope-intercept form so that we can compare the slopes. So what we need to do is now take the equation and we need to get it into the same format as the other one. So we need to solve for x basically, or solve for y basically. We need to get y by itself. So I'm going to add 6x on both sides, and then I'm going to divide 8 on both sides, and then I've got my hearts, right, and then I'm going to divide. So that becomes y equals 6/8 x plus -3. Simplify the slope, and you get 3/4. So the slope is the same between the two equations, which means these two lines are parallel. They're also parallel. We know they're parallel. Not only do they have the same slope, but they have different y-intercepts. Now, if they have the same y-intercept, well, guys, guess what? Then we have the same line twice, and they're just right on top of each other. Okay, now let's go ahead and write a parallel line for a given slope. So, to write an equation for the line, we need to use the slope from the line given, and then use the point from the line that needs to be on the new line. So we take something from the old and something from the new. Well, the something from the old is the slope. The something from the new is the point that that line has to pass through that also has the same slope as the other one. So now that you guys are familiar with point-slope form, which we talked about yesterday, we can use the slope and we can use the point to then figure out the equation. Okay? So let's go ahead and do this. So we have the point-slope formula, which is y minus y equals m times x minus x. We know y1, and we know the slope is m. So when we plug it in, we've got y minus -6 equals 3 times the quantity x minus 2. We need to simplify and distribute. I added the opposite there, so it's y plus 6 equals 3x minus 6. Move the 6 over, and we have something in slope-intercept form. Y equals 3x plus -12. So the line that has this point in it and is parallel to that line, so it's parallel to that line, parallel, Miss DH, parallel, that is parallel to that line and has that point as a solution is this line. And you can always go in and test my work by plugging in 2 for x and negative 6 for y and see if you get a true statement. Because if you do, you know that this point is on that line. All right, and you can just tell from here that the slopes are the same. So therefore they have to be parallel. Okay, next. Slope-intercept form. Yep, we know that. Yep. Okay, moving on. Perpendicular. Perpendicular lines are lines that intersect. It's supposed to be intersect. Don't be like me and proofread, guys. You gotta be able to proofread, and I obviously haven't been doing that recently. Okay, intersect to form right angles, and you guys should all at this point be familiar with right angles. Right angles are the things that have, you know, the little box to prove that they are, to show you that they are right angles. All right, so 90 degrees. All right, so properties of a perpendicular lines are two lines are perpendicular if the product of their slope is -1. So if you can multiply the two slopes together and get -1, you're fine. But the other way to think about it is that the slope of a line perpendicular to the one giving the slope, because you're going to have a line, right? And it's going to have a slope. And if you're going to find a perpendicular line to that line, the slope of the new line will be the inverse reciprocal or opposite reciprocal. Let's go with opposite, because that actually means like negative and stuff like that. Opposite reciprocal of each other. So these two lines right here that have the equation are actually perpendicular to each other, because if you were to multiply their slopes together, -1/4 times 4/1, you're going to get -1. Okay, so again, you're going to take the opposite of it, so the -1/4 is +1/4, and then the reciprocal of 1/4 is 4/1, or just 4. Okay, so that's basically how you can do it. There's not really any math you have to do as long as you can remember the opposite reciprocal. All right, so let's go ahead and work with some parallel lines. First, let's figure out some slopes. So what is the opposite reciprocal of 3/5? Well, that is -5/3. What's the opposite reciprocal of 2/4 or a half? Well, that would be +2. All right, and what is the opposite reciprocal of -3? Well, that would be +1/3, right? Because, yeah, okay. So, write an equation for the line that contains the point and the slope perpendicular to this. Is very similar to the last one I did. The only thing is because it's going to be perpendicular, the slope, we have to do something to the slope first. So the first thing we're going to do is we're going to take the slope from the line we do know, and we're going to take the inverse reciprocal of it, or the opposite reciprocal of it, which is going to give us -4/3. Now I'm going to plug in that reciprocal and the point into point slope form, and I'm going to make myself a perpendicular line. So I've plugged it into the point slope form, which again is y minus y is equal to m times x minus x, where the second y is from the coordinate point and the second x is from the coordinate point. So now I'm going to go ahead and distribute and simplify. Distribute it. So -4/3 times x is -4/3 x. And then -4/3 times -1 is +4/3, because a negative times a negative is a positive. All right, now I'm going to add 8 on both sides, and I'm going to get y equals -4/3 x plus 9 1/3, because this is 4/3 is the same as 1 1/3, and then we're adding 8, so that's 9 1/3. There you go. All right, moving on. I believe this is the last slide. And it's a bit of a word problem, but it's almost the exact same thing we did in the previous slide. So I'm going to go through this really quick. A biking path, which I think I call a jogging path later on, but hey, I'll just correct it when I get there. A biking path for a new city park will connect the park entrance to the park road. All right, and it's really hard to see, but the park entrance is right there. It's that red dot right there, and that's the same red dot right there. Okay? And they also give us points here and here, so these things are going to be important. All right, so the path will be perpendicular to the park road, which is what you can see right there. All right, we're going to write an equation for the line representing the bike path, or whatever path it is. Your book's one point calls it jogging path, one other calls it a biking path, whatever. All right, but the process is still the same. The first thing we're going to do is find the slope of the line we know. We have a line here, we have this line here, which is Park Road, right? And we know 2 points on that road, which is the 4, 5 and the 2, 1. And then what we're going to do is we're going to find the slope. So we find the slope, and it ends up being 2. Just plug it into the slope formula, which you guys should start memorizing. y2 minus y1 over x2 minus x1 is slope, okay? So then we're going to use that, and we're going to take the opposite reciprocal of it, and we're going to get negative a half, right? Flip it and then make it negative, or the opposite of. And then we're going to use that and a point on the line that we know it is. So we know that the biking path is actually this red line here, which means we need to pull the point from that red line, which is this right here. Okay, that kind of mustardy color, right? And it's mustardy color now on the other one. So we have to use that point. We're not going to use points from the yellow line because we're not using that line anymore. Plus, we know it's going to work anyway because we had to pull a slope from there, all right? So even though now we're doing the inverse reciprocal of it, okay? Or the opposite reciprocal. So we have to use the point that the new line is on. So the new line is on the point 4, 0. So that's what we're going to use in our point slope form. So there's point slope form. We've got y minus y is equal to m times x minus x, where the second y is 0 coming from there, and the second x is 4 coming from there. Remember, they're coming from our points. And then our slope, which was the negative 1/2, is coming from the opposite reciprocal of that. All right, solve for y, and you have y equals negative 1/2 x plus 2. This is in slope-intercept form. If you want it, you could put it in point slope form, but it's not going to, or standard form, but it's not really going to do you any good. So the line here, the line represented right here, is the line for the bike path, right there. Okay, well, it's a bike path. I told you I made a mistake. All right, there we go. That is it. I am done. Good luck with parallel and perpendicular. They are a little crazy, and make sure you don't mix them up. Mixing them up could make your life a little hellish. All right, bye.